PA1? Submitted?
Yeah.
How about PA2?
I've started it.
Have started it?
Yeah.
Okay, that's good. That's good.
Great.
Starting's good. Yeah. PA2's due, when is it due? Tomorrow? Tomorrow. PA2's due tomorrow, so make sure to start on PA2 as soon as possible. All right, it is now 12:30. We're recording. It turns out, I don't know what happened, but on the media gallery, I checked on Canvas. Yesterday's lecture, the file has been corrupted and is not showing. So I'm also going to be recording on Zoom, right? So if anything were to happen, we can upload this new Zoom recording. So apologies if you still cannot see the video from yesterday's lecture. We're going to try and get that up and running very soon so that you can get that video. But if it's lost, I sincerely apologize. It's about like this podcasting system of UCSD. But if you do have any questions about while loops and things like that, things that we covered yesterday, please go to tutor hours and office hours and TA hours, all the help hours that we have. Okay? So, welcome back everybody to another wonderful lecture for CSE 8A, Intro to Programming in Python. Today we're going to be covering references and objects. Okay. Heads up, references and objects, I think is probably notoriously one of the hardest concepts to get your head around, right? It's not something that like we're going to have to do like programmatically a lot. It's not something that, it's like more about the idea of computer science and how our computer is looking at and using data, okay? But we're going to go again step by step. And if you have any questions whatsoever, please do not hesitate to ask your questions. I am more than happy to stop lectures to go over anything that we have for references and objects, because references and objects are like a kind of a tricky thing to get your mind around. But we'll get there. We'll get there when we start off on references and objects. So some quick announcements again. PA2 is due tomorrow, and PA3 is being released today. Okay, PA3 is being released today. Our PA team back there is working diligently to make sure that it's going to be out and ready to go by I think like 5 or 6 p.m. today. Yeah, make sure that you are working on your PA2 because it is due tomorrow. All right, and there's I think there's like 3 coding challenges on that one, right? So lots to do. And if you have any questions, again, go to any of the office hours that we have, and also use Code Help if you are kind of stuck and it's like the middle of the night. Hopefully you're getting rest and sleeping, but if you're at a time where there's no office hours being offered, then don't hesitate to use Code Help. Okay? And then also, lab is today. Lab is today in the CSE basement. Lab has mandatory attendance to get full points, so please go to lab. Okay? Sound good? Great. Now, the midterm. Next week is the midterm. It is in less than a week away. It is next Wednesday, July 16th, during class time. Okay? And we will, during class time for the midterm, we will not be in this room. Okay? For the midterm, we will all be meeting at the CSE basement. Okay? Where you always have your labs. Next Wednesday, do not show up here. Show up over there. Okay? Show up at the CSE basement. We will send out an announcement again on the day to remind you all that we are going to be at the basement. But remember, we will be at the basement, okay? Because we're going to be doing the midterm online, right? On a computer, I mean, on the computer. And we'll be using Edsten. And we want you all to be at the computer lab, okay? So if you don't have access to a computer, that's okay. We have the computer lab there for people to be able to take the exam all at the same time, okay? There are going to be some short answer questions similar to what's covered in discussions. Highly recommend you all go to discussions. Chahui, I think, was quite lonely yesterday. No one showed up to discussion, unfortunately. But please head out to discussions, because there you will find some short answer questions that are very similar to what's happening in discussion and for the exam. We also have some multiple choice questions and choose all that apply. For questions, we also have some explain in plain language questions, aka just tell me what's happening in this function. We'll go over one of those right now. And then also there's going to be one coding challenge. Okay? So you will actually have to program within the time frame of the midterm exam. Okay? It's also going to be closed book and closed notes, so you cannot bring your own notes. But we will be providing a reference sheet. So like, you know, certain list methods, string methods, a couple of things that we've learned in class that will be useful. We will also be providing this for you. Okay? It will be there for you and provided. But again, closed notes, no outside notes from you. Okay? And we will also be sharing a practice midterm question bank so that we can have you all practice on some midterm questions, okay? To see what the midterm will be looking like. Again, you can also see these at discussion. Highly recommend you all go to discussion. Okay, so speaking of those explain in plain language questions, this is what it would look like, okay? Let's do it right now. So explain in plain language the purpose of the following function. We have a mystery function that takes in an argument called nums. I'm going to let y'all just read that for a second. So what is happening here? What's the answer? Yeah?
B.
B? Why would it be B? This function computes and returns the number of values in the list of nums. Why is it B?
The function takes in like a list and then iterates through like each thing in the list and adds one to C.
What is C?
It's just an int that starts at 0.
It's an int that starts at 0, right?
And it returns C after going through the whole list.
And we return C after the whole list. So we're going to go inside the list, right, for n and nums. We don't ever use n, but that's okay. We can go through the entire list. We go through it, C gets updated. C starts at 0, then we add 1, add 1, add 1, add 1 for each one. Then at the very end, we return C. So yes, we are returning the number of values in the list of nums. Very similar to what len does, right? len, it gives the length of the list. It's very similar. Okay? It's the same thing. It gives you the same output. Okay. Any questions on that? Yes, no, yes, no? All right, great. So this is what one of those questions may look like in the exam. So yesterday, we were looking at a guessing game, right? We were doing a guessing game between, I'm thinking of a number between 1 and 10, and we go through all of you to see what is the number that I'm thinking of, right? Today we're going to do an updated one, okay? This is a quick code example for a guessing game. Here we have, whoops. Oh, that is going to be an issue, isn't it? Okay, here we go. That's fine. Here we have some code. Let's look at it here. Pull that up. Bring this over here. And let's make this a bit bigger. Okay. So I have this new game for you all. And it's a similar guessing game. But right now, we're going to be guessing where to go eat at UCSD. Okay? UCSD's got a couple things. Here's a couple of my favorites, right? Here's some options. Okay, the very first thing we do is we import random. What does import do again? What is import doing?
There's there's code that was like that someone made and just importing it into your IDE.
Yeah. So you're importing it, to your IDE. IDE, for those that don't know, is your is basically where you write your code. That's all it is. Okay. So yes, you're getting someone else's code. Someone wrote something for random that does some really cool things that we want to use, and we're bringing it in. Okay. Then we have a comment. Then we have this. This is a list of strings, and these are all places to eat at UCSD. Taqueria, Wolftown, Taqueria, Supan, Copa Vida. Okay? And I'm going to print out here your dining options. Just printing out the whole list. That's what we're going to do. Then, I'm thinking of a place to eat. Can you guess it in 3 tries? Okay? Can you guess it in 3 tries? Then you have a variable of the number of guesses because you only want to give them 3 tries, right? Then you get an index. In this case, index is going to be a random integer from 0 to the length of options minus 1. Why do we do length of options minus 1? For the index, for indices.
The list starts at 0.
List starts at 0. So if a list starts at 0, even though we have 1, 2, 3, 4, 5 things in here, there's 5 things in here, when we count them, it should be 0, 1, 2, 3, 4. Okay? So when we're creating a random integer, some random number, we want a random number between 0 and 4, not 5, 4. So that's what we're doing here. Right? Now, we have our secret word. Our secret, like the place that we want to go eat. Because we're going to get to options, our list, and we're going to go to the position of index. What number is index?
It's random.
It's random. We don't know yet. It's a random number between 0 and 4. All right? So, let's just look at what this looks like right now. Let's run this. Okay, great. We have our dining options. That's what we printed here. Then we print out, I'm thinking of a place to eat. Can you guess it in 3 tries? Sounds good. We're going to try and guess it in 3 tries. So, what can we do now? We can start our game, right? How can we start interacting with someone over and over and over again? Yes, input will be asking the user something, right? But what we want to do is start off our game, and what we can do is we can use a while loop, right? Our while loop to keep on playing until we find the answer or we run out of guesses. So, while our num guesses is greater than 3, right? Oh, sorry, greater than 0. So as long as you have guesses left, right? How many guesses are you allowed? 3. So while you have a certain amount of guesses left, so greater than 0, we can keep on playing. Okay? So what we can do is, my guess is equal to the input, right? Where do you think we can eat? Or where do you think I want to go eat? Okay? This is going to get my guess, right? And the user is going to put something in there, some restaurant. We don't know what it is. And then what we can do is, as soon as they guess, we're going to make their num guesses equal to num guesses minus 1, right? Because they just guessed. They used their first guess, right? So now we have, this is what they're guessing, and now I'm going to make their number of guesses go down by 1 because they had 3 total, and they just did their first one. Does that make sense why I did that? Any questions so far? Yes, no, yes, no? Okay, great. So now, we have the list of options. From our list of options, we got the secret one, the secret option. Actually, let me update this. Instead of secret word, secret option. Okay, one that we're trying to guess. And now we guessed with my guess. What do we want to do now? We're starting a game. I have my option. Where do we want to go eat? Where do I want to go eat?
Soup on.
What should I do? As soon as Tyler gave his guess, what should I do?
See if it's right or wrong.
See if it's right or wrong. Okay? We need to check to see, is Tyler's guess, or anyone's guess here, is it the right answer? So if my guess, how do we check to see if my guess is the secret option? Equals, secret option. Okay? If we got it right, we can say, hooray, you got it right. Okay? If they got it right, do we want to keep on playing the game? So let's say you said supan, and I'm like, oh, you got it, supan. Where do I want to go eat? Right?
Yeah.
I don't want to keep on asking. So if we want to stop asking altogether, stop asking over and over again, what should we add here?
A break.
A break. Break will get us out of the while loop now. We said we found what we wanted, let's get out of here. We're stopping the game. Okay? But now we also want to check if they didn't get it right. How can we check if they didn't get it right?
Else or else if.
Else or else if. Yeah, you could do one of two ways. Let's do just the else one for now. So otherwise, you say, oops, that's not where I want to go eat. Try again. Okay? Should we break here?
No.
No, because we want to keep on asking in the while loop, right? Let's do that for now. Let's run it. Let's see what happens. I'm thinking of a place to eat. Can you guess in the 3 tries? Where do you think I want to go eat? Ella, where should we go eat? Out of these options right here. Copa Vida. Oops, that's not where I want to go eat. Try again. Okay, where do I want to go eat?
Taco Bell.
Taco Villa. Oops, that's not where I want to go eat. Tyler, where do I want to go eat?
Taqueria.
Oops, that's not where I want to go eat. Try again. Dang it. Those were the 3 tries, right? We tried our 3 tries, and it didn't work out. But we want to tell the user game over, right? We want to say, oh, sorry, game over, you didn't make it. Okay? So, what we can do is, we can check to see out here if they got the right answer or not. How can we check out here if they got the right answer or not?
You can just copy the if statement.
Copy the if statement. So you can say my guess, secret option, right? So basically, as soon as you finish the while loop, you break, you get out of here, or like you either break or you finish this and you get out of here, right? But you can just check one more time. When we got out of here, did I get out here because I broke out? Or did I get out here because the number of guesses that we had, we ran out and we didn't get it right? Okay? What we can do is we can check one more time out here. So if my guess is equal to the secret option, so you can say, you won the game. Let's go eat now. Else, right? If they didn't get it right, you say, looks like you lost this whole game, bucko. I'm not eating with you. A very rude program. Very mean. But let's try it out. Let's run it. So, where do I want to go eat? Audria, where do I want to go eat? Wolf Town. Oops. That's not where I want to go eat. Ella, where do I want to go eat? Taqueria. Taqueria or taqueria?
Taqueria.
Taqueria. This. Oops. That's not where I want to go eat. Angel.
Taco Bell.
Taqueria. Oops. That's not where I want to go eat. Ah. That was hard. But look, now we say, looks like you lost this whole game, bucko. I'm not eating with you. Right? Again, very mean. But still, now we know that we lost. Right? Let's try and win this game. Man, now I actually want to see, let me see, Supan? No. Copa Vida? No. Ah, Taqueria? Aha! I got it! Where do you want to go eat? I want to go eat at Taqueria. Hooray! You got it right. You won the game. Let's go eat now. Okay? What's crazy here is that I got there on my 3rd try, right? On my last try. So, let's look at what that code looks like here when we do the very last try. So I start off with 3 guesses. I made my first guess, which was Supan. So my number of guesses goes from 3 to 2, right? Then I tried Copa Vida. It goes from 2 to 1, right? Then I tried Taqueria. It goes from 1 to 0, right? It goes from 1 to 0 in this line right here. Why did I not break out of the while loop when 0 is not greater than 0? Any guesses? Yes?
It like goes through all the code in the while loop before checking again.
That's exactly right. Yes, when I'm on my third guess and I made my guess, and now number of guesses is 0, and 0 is not greater than 0, we didn't check this just yet. We only check this when we loop all the way back up. Okay? So no guesses was 0. Yes, it was 0. But then my guess was Taqueria, and the secret option was Taqueria. So I said, hooray, you got it right. We hit break, and we leave. And we never go back up here to check. Right? The last time when we got to the last option, and we got it wrong, right? And we said, oops, that's not where I want to go, try it again. We loop back all the way up. And then when we have no guesses left, then that's when we see that 0 is not greater than 0. This is false, and we leave. Does that make sense? Yes, no, yes, no? Great. Any other questions on this guessing game? This is kind of a hard guessing game, right? Man, that was kind of tough. Let's make it just a little bit tougher. Right? Okay, so this is how, this is basically the answer that we just had. Right? We can also use, we can play this game to make it a little bit easier for us, in a way. We're using something called, dang it, let's cover that. Something called a parallel list, okay? A parallel list. Parallel list is just a fancy way to say you have two different lists and you're trying to use them together at the same time, okay? So let's implement the guessing game with a parallel list, aka having two different lists together. This second list will show our favorite foods from those places to eat on campus. So if they have a certain amount of guesses left, give the user a hint. Show the user a hint of your favorite food from that place. This is how parallel lists work. I have a list right here called options, with all these options. And I also have a list called fave foods from options, okay, with a different list. But what we want to do with this parallel list is we try to keep the index, right, the position, the same for each one. So that means that position 0 for options is taco villa. At position 0 for fave foods from options is carne asada fries. What I'm saying with this parallel list is carne asada fries is my favorite food from taco villa. Okay? That's not like Python like making the connection for us. No, that's us as programmers making that connection for ourselves. Does that make sense so far? So at 0, 1, 2, 3, Supan. What's my favorite food from Supan? Conchita, okay? That's a sweet bread. It's very, very good. I highly recommend it. Go check it out over at Price Center, okay? Not a sponsor, right? But basically, that's what a parallel list is. You keep two lists together to try and see, like to connect these two ideas together, these two lists. Let's use this right now in our code, okay? So I'm going to copy this over. Okay, that's good. Put this over here. So instead of options, I'm going to have options and, dang it. That's so annoying. Technical difficulties here, everybody. Sorry about that. Something that's really annoying. Actually, this is a really good teaching opportunity. Remember when I said that Python is very, very specific about things? Well, one of those very specific things is that these like little quotation marks, they have to be the exact character of a quotation mark that it wants. This is a different style of quotation mark here that is used on Google Sheets, and that's what's causing this error. So bear with me while I do this. Any questions while I'm doing this little tedious task? Any questions about what we want to do? No? Okay. So now we have our options, right? I expanded it now. It's not just up to Copa Vida. Now we also have Santorini, Tapioca Express, and Showa Ramen. Okay. So we added more, so it's going to be harder for us. But now we have these favorite foods. And we make it a bit easier for us by having a hint, right? We want to give the user a hint. The way we can do a hint is we have our secret option, right? We do it the same way. How do we get the favorite food, fave food, from secret option? How can we get that favorite food? Remember, we're using parallel lists. Yeah?
Like go into the favorite foods from options list.
Fave foods from options list.
And then do like the hard brackets with index inside.
Index inside. Why index?
Like the lists are like aligned so that like the same number on each of them like gives you the corresponding food.
That's exactly right. Okay. So if our random number is 3, right? 0, 1, 2, 3, and we want to go to Supan, we want to go to that same position of 3, right? 0, 1, 2, 3 to get Conchitas, okay? So what you can do is, index is that random number. In this case, let's say it's 3. That means secret option is options at 3. So we want to get fave foods from options also at position 3, okay? At that same position, index, index. Does that make sense so far? Right? Of using the parallel list? Cool. So, now, with this, what we can do is, we have, if my guess is secret option, sure, you got it right. Fantastic. We don't have to do anything else. Right? But now, what we can do is say, if they got it wrong, we say, oops, that's not where I want to go eat. Try again. But now we want to give them a hint if they have, let's say, 2 guesses left, right? Or 1 guess left. They have 1 guess left. How can we check to see if they have 1 last guess left? I'm seeing some hands that may want to raise. I'm seeing some ideas. Yes?
Like an if.
An if statement.
Number of guesses equals 1.
Is equal to 1, right? So that means that if your number of guesses is equal to 1, you have 1 last guess left, right? If you have 1 last guess left, then we can say something else. We can say, print, here's a quick hint. My favorite food from there is, and then we say, fave food from secret option, right? This is the string. The favorite food from the secret option. All right, let me change this. This is a really long name. Secret option food. Then look at secret option food. Okay. So secret option food is right there. Ah. Do we have it? Yes, it's still there. Okay, great. So now when we run this, we can say, here are your dining options. Taco Villa, Wolftown, Taqueria, Supan, Copa Vida, Santorini, Tapioca Express, and Showa Ramen. I was thinking of a place to eat. Can you get some 3 tries? Tyler.
Showa Ramen.
Showa Ramen. Oops, that's not it. Let's try again. Angel.
It's Taqueria.
Taqueria. Oh, you got it right. Okay, dang. I wanted to get to the last one. Let's get to the last one. So this is Taco Villa. Oops, Taco Villa again. Or actually, Ella, where should we try? Supan. That's not it. But now, we say this. Here's a quick hint. My favorite food from there is chorizo egg hash. Okay? Chorizo egg hash. And now, we can try and guess, like, what place is going to be serving chorizo egg hash? I don't think I'm going to find that like at a ramen place, so I'm not going to try that, right? Tapioca Express, that's where they should serve like boba and stuff. I don't know if it's going to be there. We already tried Taco Villa and Supan, so those are out. Santorini, that's like a Mediterranean food. I don't think they'll have chorizo egg hash there. We remove that. So now we just have Wolftown, Taqueria, and Copa Vida. Now we made this game a little bit more interesting. Now we can try and get, okay, let's try and guess. Audria, let's make a guess. Favorite food there is chorizo egg hash. We know it's not Taco Villa, we know it's not Supan. Wolftown. Let's try. Oh, no, it wasn't that one. Unfortunate. Okay? That's unfortunate. Next time we can actually say, maybe we could tell the user what it was, right? Because now I'm actually curious. Where was that? I'm not eating with you. I'm going to, whoops. Yeah, I'm going to, and then we can put the secret option, right? So now when we run it, we can say like, I don't know, Taco Villa. It's not there. Wolftown is not there. Spicy miso ramen. Where could that be? Showa ramen. Hey, we won the game. Okay, now I'm gonna try just like a random one, A and B. Now it says chorizo egg hash. I don't know where that is. Last time we said Wolftown. Let's try that one more time. It's not there. Oops. Looks like you lost this whole game, bucko. I'm not eating with you. I'm going to Copa Vida. Copa Vida was where the original game was. The original place was the secret one. Does that make sense? Right? Of how this like parallel listing works? Okay? And that's the importance of using like this index, right? This position. This position is very important. Okay? Because that way, the position is very powerful. Now instead of just looking at a list and finding the position within a list, now you can get two different lists and use them together, right? And looking at the position of both lists at the same time to get some information. Does that make sense? Yes? Great. Cool. Let's move on over. Alrighty. Alright. So, let me move this out of the way. So, here's a quick exercise on while loops. Hour of the day, invalid hour of the day, input an hour of the day. So, this program right now is asking for something, the hour of the day, right? And then while something, if something is true, we want to go inside the while loop, and we want to say invalid hour, valid range is 0 to 23. And then you ask for the hour again. Okay? And at the very end, you say valid hour answer. Thank you. Okay? This is going to be a very similar type of question for the midterm as well. Choose all valid loop conditions that checks if the value of hour is not in this range. 0, less than or equal to hour, an hour, less than or equal to 23. Okay? So choose all valid loop conditions so that we can go inside this while loop. What could it be?
A and D.
A and D? So let's look at A first. We have a not, right? So not is just going to flip whatever is inside of these brackets. these parentheses. And here we're checking if the hour is greater than or equal to 0. Cool. And if hour is less than or equal to 23. Great. So if this is true, that means we have an hour between 0 and 23, but we want an invalid hour, right? So we flip it. So that's A. That's great. Then you say A, which one else?
D.
D. Okay. D. If the hour is less than 0, what are numbers less than 0?
-1.
Negative numbers, right? Negatives. And then hour is greater than 23, so 24 and up, right? Then that means that if they give you somewhere there, then you can go inside here. That's great. That works. What about B? Oh, B is the same as this one, so it's checking to see if it's inside those hours, right? What about this one? If hour is less than or equal to 0, which is what we want, and hour greater than or equal to 23, why would this work?
Because it's equal to 23. So
It's
some,
equal to 23.
So some is 23 should be fine.
Right. What about this? And. Because it's an and, right? Let's do a random number. Let's do -1, okay? Hour is less than or equal to 0. -1 is less than or equal to 0. Is that true or false? That's true. And hour is greater than or equal to 23.
False.
That's false. But we need true and true for this song to be true. But since one of these is false, this whole thing is false, which means that in here, we go inside.
Oh.
Or wait, actually, no. We don't go inside. We don't go inside there. What am I talking about? Wait, what? No, you're right. Yeah, that should be fine. That should be fine. Sorry about that. Yes, that's totally fine. Since this is false, we never go inside here into the loop condition, and we print out valid answer now. Okay, sorry about that. Great. I just wanted to check all A through D, and I thought I had a trick one there, but no, I don't. Does this make sense about while loops? Awesome. Here's a quick exercise. We're running a little short on time that I want to get into today's lecture, so I'll just let you know what happens here. What will happen when we run the following lines of code? We're importing random, so now we can use the random and all the things that random can use. We have a list of words, live, love, and laugh, right? And now we're saying words at position somewhere at random.random 0 to the length of words. Okay? Length of words is 3. So we want a random number between 0 and 3. In this case, it's inclusive. What's going to happen is any of the 3 words that live, love, and laugh will be printed always without any error. Is this true? Yes or no? No. Why not?
It's not inclusive.
Yeah, this is not inclusive. So since rand int is doing 0 inclusive and length of words inclusive, length of words is 3. What's words at position 3? 0, 1, 2 is not there. And we get an error. So printed always without any error, that's not true. Any of the 3 words live, love, and laugh will be printed, but sometimes an error may be thrown. That's true. Okay? Because we can still get 0 or 1 or 2, but we could also sometimes get 3. And that's what's going to give us an error. Okay? Any questions on that? No? Awesome. So, why would we use a for loop versus a while loop? When do we use one or the other? Here we have a scenario. You're writing a loop to validate a password entered by the user. If the user's password does not meet the criteria of at least 8 characters, you should prompt the users to try again. Which loop will you use here and why? You're asking for a password.
While.
A while. Why would we use a while?
Because the condition needs to be true in order, and it could just be running until it's true.
It could be running until it's true. Okay? So here, we're using a while loop, and I like what you said. We're running it until it's true. Or sorry, yeah, we're running until it's true. We're running until we find something. Right? In this case, we're looking for the user's password. We don't know how many times we're going to ask. We could ask 1 time. We could ask 1,000 times. We don't know that. Okay? So that's why we want to use a while loop, because we don't know when we want to end. Okay? Or we don't know how many times we have to ask, or how many times we have to do something. How about this? You want to loop through a list of student names and print their names in a specified format. Last name, first name. Which loop will you use and why? A for loop. Why would we want to use a for loop?
Because there's already like a pre, like, there's always like, there's a like the index already. So you can just iterate through the index and find the what you need with the for loop.
Yeah. So with a for loop, yeah, you basically have a start and an end. You know when you're going to end. When are you going to end? At the end of this list. This list may be 5 students. It may be currently 3 students. Or it could be 1,000 students. But we'll know exactly how many students we have in the list. Okay? And then we'll be able to go, using our index, to go and see exactly what's inside to print it out. Okay? Does that make sense? Yes? Of why we would want to use a while loop versus a for loop? Okay? Awesome. So, for today, we're covering something called references, objects, and methods. So, references and objects, this is going to be the big one, right? References and objects. Some methods, we already covered some methods, but we're going to cover just a little bit more to really solidify the understanding on that. But, references and objects, okay? Let's look at the following string. 3235 Voigt Drive, La Jolla, California, 92093. That's an address, okay? In Python, we can also call this an object, right? The string object. It's something, right? It's something. But we can refer to that address as different things, okay? So I could refer to that as my office. I call it my office. That's my reference for it. All of you may refer to this as the lab space, right? Whenever I have to go to lab, I go to this place. 3235 Voigt Drive, La Jolla, California, 92093. That is a reference to that object. Lab space is the reference to that object. And we could refer to this space as many different things. I could call it my office. I could also call it lab space. I could call it computer room. I could call it my meeting rooms. A lot of different references, things we call those things, references to that same object. That object never changed, right? That object stayed the same. It's the same address the whole entire time. But we can refer to it as different things, right? So I call it my office, you may call it lab space, or we can call it many different things, but this is the computer science building. Right? We could also refer to it as the computer science building. We can call it CSE. We can call it UCSD CSE. Right? A lot of different ways to call it. So, references and objects. Let's look at a quick example. Here, we have list 1 is equal to 10, 20, and 30. All right? 10, 20, and 30, this list right here, is that an object or is that a reference? 10, 20, and 30, this list right here.
An object.
That is an object, okay? That is an object. This right here. We're setting it. Just like a string, just like an int, a list could also be an object, right? List 1, is that a reference or an object? Sorry, list 1, the name list 1. This one right here, this variable name, list 1.
Reference.
That's a reference. This is the object, a list object of 10, 20, and 30. And list 1, the name list 1, right, this variable name, is the reference to that object. So whenever you call for list 1, list 1 is going to point and say, this is what I got. That's my object. 10, 20, and 30. Okay? Then, what about this? List 2, is list 2 a reference or an object?
Reference.
It's a reference, right? List 2 is going to refer to something else. List 2 is going to say, hey, that's my thing. And list 2 is pointing to this. Is this a reference or is this an object? Object, right? List 2 is also pointing to 10, 20, and 30. Okay? But list 2 is pointing to a different 10, 20, and 30. Let's assume there's a list called 10, 20, or of 10, 20, and 30 on that side of the room. And there's a list of 10, 20, and 30 on that side of the room. List 1 is saying 10, that's my 10, 20, and 30. Okay? It's that one. That one's mine. List 2 says, I also have a list of 10, 20, and 30, but that one's mine. Okay? That one's mine. What about list 3? Is list 3 a reference or an object?
Reference.
It's a reference, right? Good reference. Now is list 1. Is list 1 a reference or an object?
Object.
Almost. It's a reference. Okay? List 1 is a reference because list 1 is already referring to something else. Okay? So list 3 is basically saying, I got something, is whatever list 1 has. Okay? I don't know what list 1 has, but list 1, whatever list 1 has, that's my thing now. List 1 is its own reference, its own person, and list 1 says, my thing is 10, 20, 30. This one over here, on this side of the room. Okay? So in this case, we have 3 references, list 1, list 2, and list 3, but we have 2 objects. This list and this list. Okay? Do you have any questions so far? And it's okay if we do. We're gonna be going through references a lot today. A lot. Yes.
So there are like 4 references and 2 objects.
4 references and 2 objects. No, there's no 4th ref. Where would the 4th reference be?
Like the list 1 at the very bottom.
This list 1 at the very bottom? Yeah, so this list 1,
This is unique, right?
this list 1, since it's a variable, right, is this variable right here, this is the same thing, right? So that thing there's not a new thing of list 1. List 1 is still the same list 1. So there's no new list 1, it's the same list 1. Therefore, there's no new reference, it's the same reference.
Oh, okay.
Does that make sense?
Yeah.
Yeah.
Yeah? So like we're not creating a new thing, a new list 1. This list 1 refers to the other same list 1. Okay? Let's do something similar. Okay? So let's move this over here. Oops. I'm gonna update that. Okay? But now instead of list 1, I'm gonna call this Ismail's list. List 2 is Audria's list. And list 3 is Xiaohui's list. And Xiaohui's list is pointing to Ismail's list. Don't worry, Kevin, you'll get a list soon enough. Soon enough. I heard that, yeah. Got ears everywhere. Mm. Okay, so when I do this, right? When I do this, what I want to show is I have a list. And my list is right here. 10, 20, and 30. Audrey, you have a list of 10, 20, and 30. Where's yours? Where's your list? It can't be this one. It's right there. Audrey's got it in her arms, like a baby, right? Like this. Has it with her. Chahui, what's your list?
Over there. That's the same.
Is it that one?
Yeah,
Why is it this one?
Because this is
we're pointing to the same.
We're pointing to the same list. Chahui is saying, I'm going to point wherever Ismail is pointing to right now. I'm pointing to this 10, 20, 30. Chahui says, okay, I'm going to point to whatever Ismail is pointing to. Ismail is pointing to this list over here. So Chahui is pointing to the same exact list. Does that make sense? About references versus objects? Yes.
So in that case, it will be 3 objects and not 3 references and 2 objects, right?
Yes, this is still, yeah. This is 3 references and 2 objects. What if we did this? As promised, Kevin's list is equal to Audrey's list. Okay? How many references do we have here now?
4 and 2.
We have 4 references. We have Ismail's list, Audrey's list, Chapu's list, and Kevin's list. But we have 2 objects. This list of 10, 20, and 30, and this list of 10, 20, and 30. Does that make sense? Yes, question.
So if we have like, for example, like if we have 10 numbers inside the bracket, is it still one object or?
Great
The
question.
number doesn't matter.
Yeah, the numbers don't matter. So here we get with 20, 30, 40, 50, 60, 70, 80, 90, and 100, right? There's 10 different integers into this list, but ultimately it's all a list. All of this is still one list. The list holds 10 different integers. This is a great question. This list holds 10 different integers, but ultimately the whole object is a list object, right? When we're looking at it, we're not looking at the numbers themselves, but we're looking at the fact that it's a list. That is a list object, okay? And this list object has 10, 20, 30, all the way up to 100, right? But ultimately, this is still 2 objects, and this is still 4 references. Ismail's list refers to this, Audrey's list refers to this, Xiaohui's list refers to this, the same object, right? The same object, the same thing. And Kevin's list refers to Audrey's list, the same object, that same list, right? Does that make sense?
Yeah.
Great. Thank you for the questions. I love it. So, there's a reason why we have these 2 lists be the quote-unquote same list, right? These 2 list objects are 2 list objects that hold the same information, 10, 20, and 30, right? But ultimately, they're 2 different things, okay? This list object is not the same as this list object, okay? They're 2 separate entities, though they have the same information. They're 2 separate things. That's why when I have my list that's over here, Audrey has her list over there. But my list and her list, even though they have the same content, they're 2 different things. Right? Does that make sense? I just thought of this example. It's like having twins, right? You're a twin? Wow! That's crazy. Yeah. Let's use this as a perfect example. Angel is a twin. Angel has someone when they were born. Are you fraternal or identical twins?
Fraternal.
Fraternal twins. Okay, it's gonna be a little slightly different example, but basically, both of you were born same day, right? You're twins, grew up together literally your whole lives, right? But when you're born, you're 2 different people, right? Though you share so many similarities, an incredible amount of similarities, you're ultimately 2 different people. Okay? Does that make sense? Even further is like with identical twins. Identical twins, I think they have like the same DNA makeup. They have like the same fingerprint, I think even. Do they? I don't even know. Do they? Audrey, do you know?
Not to the same.
No? Anyways, basically.
Are you a bio?
Twins, yeah, aren't you buying for that? Anyways, just kidding. But basically, what I'm trying to say is, 2 things. Oh yeah. Tell me too. So 2 different. See, even though they hold the same stuff, right? Angel's a twin. Angel holds all this DNA, and Angel's twin also holds all the same DNA stuff. They're ultimately 2 separate human beings. They're 2 different people. In this case, the same thing. 2 different objects. Does that make sense? Great. Awesome. So, let's continue on. All right. So, jeez. Okay, so now, modifying references and objects. Okay? We've had these references, right? These lists with different list names, and those are the references. And we have the list objects themselves. They're their own things, right? Excuse me. Whoa. So, something that we should know is that when we're changing stuff, certain data types are something called mutable, aka they can be changed. Okay? That object itself, this will change. Okay? it'll mutate. It's mutable. It will change. Okay? It's the same object itself, but that object itself will change. However, strings and integers are immutable. They cannot be changed. Okay? If we have a number 27 that's right here, that number 27 will never change. That number 27 will stay the same forever and always. Okay? I can be a reference, right? And I is my number, 27. That's my number, right there. Okay? But that 27 will never change. But we can also modify references. So, actually, that was going to be a little bit tougher to understand really quickly. So let's do this really fast. So, like I said before, Ismael's number of 27. Okay? I'm saying my number is 27. I'm pointing to it. It's right there. 27, that is my number. Heck yeah. Okay? But when I do this, 13. When I do that, this is going to be a really tricky one. Okay? This is where it gets a little tricky. In this very first line, it is my number. It's my number. That is the reference. And I'm saying that number 27, that is my number. Okay? Then we read line 2. And Python sees, I'm about to set something to this variable name called Ismael's number. Right? But Ismael's number, I already existed. I was right here, and I was pointing to that 27. When I do this again, I'm basically erasing everything that was here. The original Ismael's number reference, gone. Okay? And we're going to overwrite with whatever the original Ismael's number was saying, 27, that's mine. Now we have this reference, and Ismael's number over here is saying 13, that was mine. Okay? It's going to be a little bit tricky to get it around. Right? So, this reference is pointing to a 27 that cannot change. And then I'm going to overwrite it and say, whatever you had before, forget it. Okay? You are going to have something new. And this new Ismael's number, now over here, I'm going to say 13, that's my number, 13, and it will not change. Does that make sense so far? This is kind of a tough topic to go around. Okay? But now let's do this. List of 27. Okay? I have this list of 27. That's my list. It's mine. 27. It's right there. Okay? But when I do this, plus 13, right? When we did this, is this object the same as this object? No, right? This object, this reference of Ismael's number was pointing to this list of 27. It's going to grab it. It's going to add it to 13. And now we have 27 comma 13 here, right? And that's this new object of 2713. That's a new list. That's a new thing. And we're going to set that to a reference called Ismael's number. Ismael's number used to be 27. I was like, that's mine. And now we're going to erase all that. And Ismael's number is now, it's going to say 2713. That one's mine. Okay? Is that making sense so far? Similar to what we saw right before, right, of the integers. This is where it gets a little bit tricky now. Lists are something that are called mutable. Okay? We can mutate the list. Does anyone remember how we can, let me leave that one like that. Does anyone remember how we can add to a list again, other than string concatenation? There was, yes?
Like append it.
Append, right? There's this list method called append. So, this one's number, append. 13. We could print here Eastman's number. So at line 1, I'm saying my number, or like, I guess my list here. I'm gonna update it to list just so it makes sense. Sorry about that, folks. Eastman's list. Eastman's list. Copy that. Put that there. Put that there. Put that there. So Eastman's list on line 1 is me right here, and I'm saying my list is that one right there, and it holds 27. Great. Line 4 is going to append 13. So basically, wherever I was pointing to, that list is 27. I'm going to grab this list, and I'm going to mutate it. I'm going to change it and add 13 to the list. Right? I grab the 13, I put it in there. It's there now. Now, 2713, that's that same list. Okay? It's that same list. But I changed it. I mutated it. I grabbed it, I opened it, and I put 13 inside it. But it's that same list. Okay? So when we do this, when we run this, we see 27 and 13. Here, I never had to make Ismail's list is equal to something else, right? Because when I do this, dot append, this list method knows I'm going to go ahead and add 13 to that existing list, right? That existing list, rather than this. When we did this other one, is me saying that list, okay, sorry. So with append, I grab it, I open it, and I put a 13, and it's that same object. But when I do this, right, let me comment that out. On line 3, instead of grabbing it, mutating it, and making it and changing what it was, this line is going to say, hey, that list over there that was just 27, I'm going to grab that one. I'm going to use that information to make something new. This is a new list object of 27 and 13, and this minus pointer is going to go over there. Now I'm pointing at this other object, right? So do you see the difference between these two things? One of them is setting this minus list, this reference, to a new object somewhere else, whereas this one, this minus list append 13, is pointing to that original list and grabbing it and mutating it and changing it. Okay? Do we understand what's going on there? Yes? So a list mutation, right? Lists are mutable. So let's look at this. We have list 1, it's equal to 10, 20, 30. And we have list 2, also to 10, 20, 30. Are these the same lists?
Yes. Oh, no. Well,
These two are not the same lists. They're two different objects, right? They hold the same information, but they're two different lists, right? They have their own identities. Now, list 1 at position 1, we're making it into 40. So what that's saying is, we're going to go look at list 1. We're going to go to the position 1, right here. And we're going to go, and we're going to mutate it. We're going to go to that list, and we're going to change that number 20. We're going to take it out, and we're going to get 40, and put it in its place. Literally in its place. So we're going to change that 20 to be a 40. Right? That 20 is gone, you grab it and throw it away. And you get the 40 and you put it right there at that position 1. Okay? So now we have mutated that list. Okay? It's not a new list. It's the same list, but you're updating its value. Okay? Let's look at this code in Python Tutor. Python Tutor. Hopefully this will show another nice example of the visualization. Okay, so, oh, actually, why am I showing my face? I could just done like that. Anyways, we read our first line. List 1 is equal to 10, 20, 30. List 1 is pointing to this list, right? Of 10, 20, and 30. Whoops. List 2 is its own other thing, and it's pointing to a different list. Also 10, 20, and 30. But they're two different lists, right? Two different lists. Then, our next line. List 1 at position 1 is now 40. So the system went to list 1, went to the actual object itself, right? It went to position 1, and it changed it from 20 to 40. And now we can print out list 1 and list 2. So when we print out list 1, it's going to look like that, 10, 40, and 30. And when we do list 2, 10, 20, and 30, this is pointing to that, this is pointing to that, and they have their own outputs. Does that make sense so far? Of two different objects, things like that? Now let's look at this. This is a little funky one. Let's go. Here. Okay. There's another execution. All right, so now, line 1, list 1 is equal to 10, 20, and 30, this list, right? This list object. Great. List 2 is equal to list 1. What did I say happens when we do this? Is this list pointing to a new object or the same object?
To list 1. So.
It's pointing to whatever list 1 is pointing to. So it's going to point to the same object. So check this out. We'll click next. List 2 is not pointing to a different list of 10, 20, and 30. It's pointing to the same list of 10, 20, and 30. All right? Does that make sense? That's why I was trying to do that whole, I'm a person pointing at this. This is another person pointing over there, right? To show two different references to two different objects. Versus when I have my list right here, and I'm pointing to it, and then Chakui, he's pointing to the same list that I'm pointing to. This is exactly what I was talking about. Okay? List 2 is pointing to the same list that list 1 has. What does that list have? List 2 says, I don't know, but I'm going to point at it. That's mine now too. Okay? So now, when we go to this line right here, list 1 at position 1 is equal to 40. We are mutating the list, this same list, right? We click next. When we mutated list 1 to its object, it goes and it changed it, it took out the 20 and put a 40 in it, right? That's good so far. But now list 2 is pointing to that same object, right? So whenever that object updated, because of list 1, list 2 is pointing to that same thing. So when we print out list 1, it's 10, 40, and 30 up here. Then we print out list 2, it's also 10, 40, and 30. Does this make sense? Because it's the same object. It's the same thing, right? Do we see the difference between these two things now? These two different boxes? One of them has two different objects, and list 2 will not be updated. But this one on the right has one object of this list, 10, 20, and 30. So when you update this one, when you mutate it, when you change it, even though we changed it using this reference of list 1, when we print out the reference for list 2, it's referring to that same object. Therefore, even though list 1 updated it, list 2 also gets that update. That make sense? Awesome. How am I on time? Oh, geez, I only have 10 minutes left. Oh, boy. Okay, so what's going to happen here? We have list 1 of A, B, and C, and list 2 of D, E, and F. what will be the answer when we print out list 1 and then print out list 2? Any guesses?
A.
A? D, E, F, D, E, F? Let's check it out. Let's grab this. Let's go to Python Tutor. I'm going to edit this code. Put it in there. Visualize the execution. So, we start off with list 1 is A, B, and C. Right? Here's list 1. It's pointing to A, B, and C. Great. Good so far. Then list 2 points to a different list object. And list 2 is saying, I'm going to point now over to this, D, E, and F. Now we look at line 3. Line 3 says, list 1's reference will now be pointing to list 2. Okay? So now list 1 and list 2 are pointing to the same object of D, E, and F. All right? D, E, and F. Then we say list 2 is going to be pointing to the reference of list 1. Where's list 1 currently pointing to right now?
List 2. Oh, D, E, and F.
To D, E, and F, to this object. So now you're saying list 2, I want you to point to wherever list 1 is pointing to. Well, list 1 is pointing to whatever I'm pointing to already. So when we go to the next line, it's pointing to the same thing still. So now, when we print out list 1, that's D, E, and F, and list 2, that's also D, E, and F. Okay, so you got it right. Good stuff. Does that make sense? About references and objects? Yeah? Let's look at this next slide. Modifying a list within a function. So remember I said that lists are mutable. You could change them. Okay? That includes whenever they go into a function. Let's look at this function right here. Add 1 nums, right? This function called add1 takes in a list of numbers, nums, and for I in range of the length of the numbers, so we're going to go through each position, right? Position 0, 1, 2, 3, all the way up until the end of the list. And it's going to go to that list at that position, and it's going to update it to whatever it was before, and add 1. Right? Remember what plus equals is? What does plus equal do again?
Nums I plus 1.
Yeah. So nums I plus equals 1 is the same thing as saying nums I equals nums I plus 1. Yeah. Okay. So what this does is it goes in to the list and updates each number with 1. So now we have this num list of 10, 20, and 30, right? Let's put this in Python Tutor. Edit the code. Boom, boom. Visualize execution. So now, we have this function, right? And the system says, okay, I know there's a function. I don't need to read it yet, but I know it's there. And anytime we call it, we'll look at it. Num list. Num list is pointing to this list object of 10, 20, and 30. Great. Let me print that out. Now it's printed up here, 10, 20, and 30. Then, I'm going to get my list called num list, and I'm going to take it into the function, and I'm going to call it nums while I'm inside this function, right? But this nums is a reference, right? But this nums is referencing the same exact list. It's not a new list. It's not a similar list. It's not an identical list, just like identical twins, right? It's not an identical list. This is the same exact list. So that's why right here with these arrows, nums is pointing to this list. Okay? Does that make sense? This nums is pointing to this list. So that means when we go into the for loop, for I in range of length of nums, I we start off at 0, right? I is 0 right here. We go to nums at position 0, which is, what's nums at position 0 right now? 10. And we're going to make it equal to 10 plus 1. And now we updated it to be 11. Okay? And we do that for the whole list, right? Now I is 1. It updates the list at position 1, which is 20, now it's 21. Now I is 3. I goes to position of the list at position, it's 2. Now it goes to position 2, which is now, which was 30, now it updates it to 31. It adds 1, right? Then we finish with the function. We don't return anything. We go back and we finish our function. We go to the next line. And now we're going to print num list. And when we click next, num list is now 11, 21, and 31. Right? We never made num list equal to something new at all. Right? But what we did do is we went into that list and we grabbed it and we changed it. Right? We mutated it. Does that make sense so far? Of how that works? Yes? Any questions so far? No? All right. So that's us modifying a list within a function. This exercise, clear list. Let's skip this exercise for now, but I highly recommend y'all copy paste this into Python Tutor so you can see, visualize what's happening. Okay, I'm only skipping it right now because of time, right? And I want to finish up the lecture. So what about strings, right? Remember strings? Are strings mutable or immutable?
Immutable.
Immutable. Strings, you cannot change that string. All right? You cannot change it. So, whoa, Chahui, you're getting ahead of me. Copy that over here. Okay. So, we have update first character, right? This function is going to take in a name. And the name at position 0, we want to make it equal to A. Name is Annie. Okay? And we want to update that first character. And we're going to print out that first character. So in theory, what should happen here is that we get this name. We go to name at position 0, right, this A. And we're going to change it to this character, a capital A. In theory, what we want to see happen is that when we print out name, it's going to say Annie with a capital A. In theory. Let's run it. Waiting for the server. Here we go. Okay, so now what's happening here is that Python gets mad at us. Okay? And it gets mad at us because strings are immutable. Okay? You cannot change that string object. It is immutable. So when we did this, right? This line right here. I'll just do it like that. When we did this line right here, this line is trying to do the following. It sees a string. It's that string right there. It's going to go over there, grab it, and it's going to try to change that first character, whatever it is, at the 0th position, and change it to the capital A. But Python's going to say, no, 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 no. You cannot do that. Because strings are immutable. And if you're trying to change that string, I'm going to lose my mind, and I'm going to get an error. Right? And we see this error right here. String object does not support item assignment. You cannot update it. You cannot change that one. You could look at it. So let's do this. Right? Comment all that out. We could do this. Print name at position 0. Can we do that? Let's run it. There's no errors. We see the letter A. Okay? We can look at it. There's that string. I want to see what's the very first letter with name at position 0. Right? I want to see, I want to see what that name, what that first letter is of that string. So I get to the string name and I look at position 0 and I can see it, but I cannot change it. I cannot change the string. And why is that? Strings are immutable. Because strings are immutable, you cannot change it. So it's going to get mad at you. Okay? Even though you can look at it, you can look at it all you want. Name at position 0. But you cannot change it. Does that make sense? Awesome. How much time do I have left? Oh, no time left. Oh, I did it! I did all the odd things I wanted to look at. Okay, great. Man, we're all caught up now. All this other stuff, this is extra stuff that we had before. You know, just like the append stuff, right? There's this new list method called insert, which is basically grabbing whatever you want to add, and you put it at that position. But you can copy paste this over to Python Tutor. Let's do that really fast. I'll go over by 1 minute. Really sorry about that. But this list method, right? No adds things. This is method. So we have this names list called Ismail and Anshul. We can print the names Ismail and Anshul. Then we can append this name called Bill, right? So Bill is now in that list. We print it out, Ismail, Anshul, and Bill. Then we have this thing called insert. Insert basically gets the position of where you want to insert into the list. In this case, I want to put it in the position 0. And I want to put in Gerald. Okay? So it grabs the string Gerald, it goes to position 0, puts it in there, and